what I'm going to try and do is make separate films for the different parts. There aren't that many different parts, are there? Whoops. Oh no, where am I going? But should we just go through the 4 exam questions?
Yeah.
And we'll start with the math. Okay. So we're going to go through on this film question 1 from the first and so far only test exam. I don't know if you all have it in front of you, probably not. Not everyone, no. It's fine, it's just like whether I need to try and make it visible on the screen or not. So how did has everyone had a look at the questions? Yeah. Any thoughts or like?
The first one was really difficult.
The first one was, yeah. I think the second one was easier than the first one, wasn't it? The first one was definitely felt like, okay, once I'd done the 2, I was like, well, this second one is a lot easier. Did the rest of you think that too? So you said it was really difficult, so you couldn't solve it, or?
I'm not sure I got the right answer.
Okay.
And I had some question about the later part.
Yeah, so it was actually quite unclear at one point what I was really after. That was the specific thing I was thinking of where it should have been clearer. Was in the part B. It's like, what economy are we really in? It wasn't specified. Is it laissez-faire, or is it a planner, or? Yeah, so this one definitely, when I was finished with this, it was like, okay, this is okay. I don't have time to do another one. This will do. But I was thinking, okay, this is definitely quite tricky. Like, you certainly won't get any question that is trickier than this. This would be at the outer limit. Well, look, certainly. I can always screw up and think a question's easy and then you find it really hard. But this one I was thinking, okay, yeah, this turned out quite tricky. It's like, the math is super straightforward, but it's just getting your head around it really here. Okay, so let's have a look. So assume an isolated country in which all markets are competitive. So you need to remember that. I should say, I'm not totally sure I want to stick with this. This is quite constraining for me. So I might come up with a new way of formulating this, which isn't quite as tightly constraining, in which case I'll let you know, like on Monday. But it's not going to be radically different. It's going to be broadly like this. But I just might loosen it a bit, because, yeah, I sort of wrote this down, and then when I was starting to make exams, it's like, wow, this is really constraining me, kind of. So broadly, it's going to be close to this, but I might change it a bit. So the first one, you can achieve first best only through environmental regulations. So basically, you can assume that it's going to be perfect markets. Otherwise, yeah, you're only going to have the environmental externality. And we're making electricity in power stations, and that's obviously, it's a partial model, as always in this course. A partial equilibrium model, and we're only looking at the electricity sector. And we're extracting coal to put into that sector. Okay, so we've got power station, see, I can draw the general equilibrium as if it was general equilibrium. So this is the power station, this is the coal mine. What have we got? And the cost of generating a megawatt hour of electricity is W1. Okay. So that's the unit cost is W1. And that's basically like the cost of coal and the cost of the capital and so on you need and the labor to deal with the coal and turn it into electricity. And typically, if you've got a big sector, it's like this idea of constant returns. It makes a lot of sense. Okay. It's so common to set up these models with which don't have constant returns. But if you think about if you've got a country with 20, 30, 40 coal-fired power stations, you're basically just replicating these power stations in different places. And then if you find you need more power when you build another one, what are the costs of that 41st one going to be compared to the other 40? And it's going to be the same, to a pretty close approximation. And then, so we're sending electricity off here, and we've got this demand function. P is P naught minus Q. This the quantity Q. And in the coal, which is getting trucked into the factory, we've got sulfur that ends up in the air in the form of sulfur dioxide. And so obviously, if we don't do any abatement, this emission is going to be in proportion to the amount of coal that we burn, right? And if we've got Q coming out here, how much of this have we got coming out here? Well, you probably don't know how to say it, do you? Phi or phi, right? Phi Q, I call it phi. That's what I learned at school. So we got phi Q units of sulfur dioxide. We're not given the units, I don't think, of it. Oh, tons of sulfur dioxide. But we can also install a scrubber on the chimney which will take out sulfur dioxide completely. But there are lots of power stations now, so the unit cost of cleaning up is W2, isn't it? So, in fact, it might be clearer to say total cleaning cost is W2 times what?
A?
Right. It's not quite, we haven't quite got there yet, have we? But denote total abatement by A. So the total cost of cleaning is W2A. Okay. So we've got some in an internal solution, there'll be some power stations with scrubbers and some without. So in general, why might you have a solution with some with scrubbers and some without? If you've got these linear cost functions, shouldn't it be that it's either worthwhile to put scrubbers on them all or not? Like if it's worth putting a scrubber on this one, why isn't it worth putting one on this one too?
Does it have to do with the damage function?
It has to do with the damage function. It looked like Hannah was... Do you want to finish the answer off? Or?
No, I mean the ones with the lower minor cost.
Aha, it could be, but in this question they're all the same.
Oh yeah.
Yeah, but otherwise, yeah, that would be a reason, but not the way. We'll get there in part B3, but at this point they're all the same.
And because the damage function is squared here.
Yeah. So the marginal damages of a unit of emissions go down. The more scrubbers you put on, the lower marginal damages are for the ones that are left still emitting. So at some point it's not worth putting on more scrubbers. Okay, and that's what this part A is going to be about, is finding that point, kind of, basically. Yeah, so then we've got this damage function. So, if we collect up some equations, we've got d is theta e squared. But what's e?
By Q.
So that was our picture, this was some facts, but then let's get some equations. Just making more and more of a mess. D is theta e squared. E, I didn't hear who it was, but phi q, someone said. Seems, is that right? Yeah, it looks good to me, yeah. Because Q is total production from all the... Oh no, so it's not quite right, is it? There's something missing. It's a good start, but we need something more. Because E is total emissions, yeah, at the end of the day, so to speak.
Minus the ones we do.
Minus the abatement, yeah. And we've defined A is just how much you remove at the end of the pipe, so to speak, at the top of the chimney. So there's phi q coming up the chimneys, and then we take away A in total. So emissions out of the chimneys added up is phi q minus A. I'm just like getting this straight is like a big part of the difficulty here, I think. I don't know if you agree, but it all kind of adds up and adds to a sense of uncertainty, I think, if you're not quite sure of whether you're getting it right. Are there any more equations we should write down? So we should have this one as well. P is P naught minus Q. I think those are probably the key relations that we need. Okay. So I'm totally missing this. Or maybe I'm not actually. I think the camera picture is actually broader than what I see there. I think it's probably getting on the picture, whatever. Maybe I can try and turn it a bit. I think it's just going to fall over if I turn it, that's the problem. Okay. Right. So it's really helpful, I think, if you can think about this and see, okay, we've got these linear cost functions for everything. So typically that would be, you would then tend to be getting like corner solution. But the damage function is like marginal damages are increasing in emissions. So that is going to give you the possibility of having an internal solution. So, what's going to happen in laissez-faire? So, looking at this, we can just say straight away something about laissez-faire. What can we say about the allocation in laissez-faire? We can say exactly what one of these variables is going to be. We've got D, the variables unknowns. We've got D, E, Q, and A, and P, haven't we? We can say straight away what one of those is going to be in laissez-faire.
A is 0.
Right, there's going to be no abatement, is there? So let's just forget abatement for laissez-faire. Like, why don't make life difficult for yourself? So A1, A is 0. Okay. And then we're saying, look, the representative firm, what is that firm's profit function? If you like, the profit function for all the firms put together. So it's revenue minus costs, isn't it? So what's revenue?
Price times quantity.
Right. So, but then we need to be careful, don't we, about what we put in. So, what shall I put in here for price? Shall I put this or this? This one. Are you sure? I don't think so. Because we're going to do a first order condition here, right? So we need to be careful. So if I write it like this, and then take a first order condition in Q, I'm going to get the wrong answer. A lot of empty looks. Have a think. Talk to your neighbour. Why is that going to be wrong? I'll go and fill up the tea to give you some breathing space.
Ja, men det var fel. Om priset är givet. Men jag tror att det är på priset. Men det är inte bara
Yeah.
Jag tänker att de här pricing, jag vet inte, med alla de här villkoren så tänker jag så
Okay, so we
when you endogenously decide price. You can actually
Ja, jag tänkte när vi var på samma då tog vi inte den andra.
Jag vet inte varför så, men alltså,
what would happen? Like why
det är
would
därför
it
man
be
måste vara
choose it wrong?
Om man ja, det var, eller därför tänkte jag att man vill ha den andra.
I just know that when you treat
Jaha, just det.
kan du börja, men då kommer jag då bryter effekten
Ja, men då.
Men jag vet inte varför.
So I actually very pedagogically screwed this up in one of the videos, didn't
yeah,
I?
we did.
Might help you remember.
That's why I think
Yeah. So what?
I think you should go with only P since the firm is a price taker, right?
Right, exactly. Exactly. So here it's as if the firm's choice of Q is also affecting the price, right? Which, I mean, it seems to make perfect sense, but the point is that it's not. You're writing the equation as if all the firms are deciding together, but actually we're thinking this is one. We're thinking of a small firm that is not affecting the price. in a way, if you're going to, the theory behind it is a little bit subtle. If I'm going to really get into the details and talk about the representative firm and so on. But I think we're just going to leave that and just say, look, what Alexander just said, I wish I could just say it again. I can't remember what he said, but the firms are price takers, so just leave the price as constant, and it's price times quantity. And then later we substitute this in, yeah, after we've done the differentiation. Because we're thinking like maximize profits by choosing Q, because we dropped A, haven't we? And profits are the price which is exogenous to the small firm times Q minus what? W1 Q, isn't it? So then the first order condition gives us that price should just be equal to W1. So then we get P0 minus Q equals W1. Q is P0 minus W1. Okay, and then what are emissions going to be? Phi times Q. This Q, obviously. So P0 is a measure of demand, isn't it? So the demand function is just like this, isn't it? Price, quantity, or price, and that's P0 is here, isn't it? So the bigger is P0, the higher up is the demand curve. And then W1 is just this cost for producing, and you're going to super straightforward, basically. Okie doke. Part 2. Okay, so what's the planner going to do? So I'm going to scrub this if it's okay. We're going to stick in this little corner of the border. The map is actually simple enough that I think we can do it all in this little corner. So, the planner is also maximizing. I mean, you could choose some different notations for planner's benefits. It's really up to you. I'm quite lazy with notations, so I just call it pi every time. Like firm's profits, planner's benefits. It's a bit of a lazy notation, but whatever. So what do I need to write down now? This is a bit trickier, isn't it? So in terms of this figure, what's the planner trying to maximize on the benefit side? If we forget about abatement and so on.
Profit. Consumer surplus.
It's the surplus. It's the total sum of consumer and producer surplus, isn't it? And in this figure, it's like this area. You're going to choose Q, and so if you choose Q lower, then you're losing surplus, aren't you? But of course, in this case, you might choose Q lower because it will give benefits elsewhere with less emissions. Yep. But But in terms of the math, we want something that's going to capture this kind of thing, right? So what's an area under a curve? Mathematically, it's that we need an integral, don't we? So this is the benefits of production, if you like, is the area under the curve like that, isn't it? That's the benefit side from the production. And then we've got to take away the costs, and then we've got to take away damage costs and also abatement costs. So what's this area mathematically? It's the integral of this line between naught and q, isn't it? So it's the integral between naught and q of p naught minus q dq. Yeah? So that whatever q we choose, this will give us the area, which is as a consequence of that choice of q. Yeah? Are you happy you're happy with that? Yeah? You alright? Yeah, cool. So that's like the revenue, equivalent to the revenue term in laissez-faire. And now we've got to take away a whole bunch of costs, haven't we? So the first cost is this block here, yeah? So what's that? So that's super straightforward, yeah?
Cost of production.
Yeah, but mathematically, it's W1Q, isn't it? Yeah? Oops. What else have we got? We've got the abatement cost or cleaning cost. Abatement cost is W2A, isn't it? And then we've got damage costs by E squared. Theta E squared. Okay. We've got kind of too many variables here, haven't we? We want to get rid of a variable. Because A, we can, of course, we could do it as a Lagrangian, or we could just substitute, yeah. Because there's a link between Q, A, and E, isn't there? So we can use that link to get rid of one of these. So which of these equations should I use to try and get rid of a variable?
The E equals
Right.
I.
Phi, good. Q minus A. So we could switch this around and get rid of the A, or we could use it as it is and get rid of the E. It really doesn't matter. I'm going to get rid of the E. Okay. So that's the planner's problem. And now we set it up this way, we say the problem is to choose Q and A. Maximize by choosing Q and A, pi, which is equal to this. Okay. So now I want you to do the first order condition in Q. Have a look at that. I'll come round and see how you're getting on. Sorry, we missed a bit. Oh yeah, I never looked at you. I'll come back to it. Well, I'll go in the other direction. don't think I need to check every question, because most of you have time to do this.
Yeah.
So the first order condition in A, so we've got minus W2, and then again, minus 2 theta times this, and then we go inside and differentiate everything inside with respect to A, and we get minus 1. So that's plus then, equals 0. Okie doke. So then, if we just, I can kind of just look at this and say, look, this phi q minus A crops up in both places, but here we've just got phi q minus A is equal to W2 over 2 theta. Okay. And then I can stick that in here, W2 over 2 theta, and then I've only got Q's left here. So then I've got P naught equals Q plus W1 plus 2 theta phi times phi Q minus A, which is just W2 over 2 theta. And those 2 thetas are going to go out. And we rearrange and we say that Q is P naught minus W1 minus W2 phi. Okay. So Alexander's looking concerned, but it's just algebra, right? So don't, you can look at it later, you know. If you just write down the answer for now. Okay. Does this make any sense intuitively? Do you think I got the right answer? This is super important in exams to try to think, okay, does this make any sense? It does, okay. I haven't done anything clever and pedagogical here by getting things wrong. So why does this make sense? Can you get your heads around that, anyone, or give us some thoughts?
I'm thinking the quantity depends on that period's price, or I guess that's what P0 is.
So P0 is, remember, it's a measure of the height of the demand curve.
Ah, yeah, okay. Well, minus the...
Yeah, so the 0 isn't a time thing, it's just a sort of baseline.
Yeah. So minus the cost of production.
So it's like the bigger P0 is, the more you're going to make. And the bigger production costs are, the less the planner will... Is this planner? Yeah.
Yeah.
The less the planner's going to make. And the bigger... What's phi?
With damages. Or
Phi is linked to the amount of sulfur in the coal, isn't it? So the more sulfur there is in the coal, the less coal you're going to burn. And the more costly it is to clean up, the less you're going to burn. It's kind of interesting that there's no theta here. The theta sort of cancelled out. So we could think about that if we wanted to. I'm not sure I've got a simple answer for that off the cuff. The theta is linked to the... where's theta? Yeah, it's the link to the damages, isn't it? But apparently it's not affecting the amount of electricity we choose to produce. It certainly ought to affect the amount of abatement. That would be very odd if it didn't. So what is abatement? How much do we choose to abate? we've got this equation with A and Q, haven't we? So we can rearrange that a bit and say that A is phi Q minus W2 over 2 theta. So the amount we abate is phi times this minus this. So now the theta does appear. If theta is big, this term is small, and we abate a lot. So if theta goes to infinity, if theta is very big, what does this term approach in the limit? If theta approaches infinity. Right, so then we abate phi q. And what's phi q?
All of everything.
We abate everything. So again, it's just a little check that it seems to make some kind of sense. So we found Q. Oh, we are asked to find E as well. So what's E? Okay, yeah, so E is phi Q minus A, so we kind of set it up back to front compared to the way the question is. Because we found A, and now we need to find E. The question set up as if we, remember we eliminated E? The way the question's set up, I'm kind of assuming you're going to eliminate A. But it doesn't matter. Okay. So we found A. What about E? So E is phi Q minus A, isn't it? So phi Q minus phi Q minus minus. So E is W2 over 2 theta, isn't it? So again, if theta goes to infinity or W2 goes to naught, abatement costs go to naught or damages go to infinity, then we're not going to omit anything. So what proportion of power stations fit scrubbers? Have a think about that. Wow, time's running on, isn't it? Thoughts about the proportion of power stations fitting scrubbers? It's going to be linked to A and E, isn't it, somehow? So like, if E is phi Q, then what proportion of fitting scrubbers? Say again? You're thinking right, but you got it back front. If emissions are equal to phi Q, how many are fitted scrubbers? None of them.
None,
Yeah.
yeah.
And if emissions are 0, then they've all fitted scrubbers. So how are we going to get a proportion? Let me think. Isn't it going to be this divided by phi q, isn't it? how much we took away, and phi q is how much we started with before we take any away. So if we divide how much we took away by what we started with, if we don't take any away, then this is 0, and then what we took away divided by what we started with is 0. No, proportion 0. If we take away phi q and divide by phi q, then the proportion is 1. So the proportion is 1. I'll squeeze it in here. So it's A over E, isn't it? No, it's A over phi q, sorry. Which is 1 minus W2 over 2 theta phi q, where this is the q. Okay, so quite tricky. So you said, I'm curious, you said you weren't sure if you got it right.
Mm.
How is,
I didn't get it right.
you didn't get it
But
right?
I missed the A on emissions. Or I only wrote the emissions as phi q. And yeah.
Right, so it's kind of like what I was saying, it's sort of getting the setup
Like once
right
you get,
is crucial.
once you have those, it's quite second.
Yeah. So I don't know if the others of you worked through it and did answers, like how anyone else?
We did it like together because we did it together.
Okay, yeah. Yeah, it's certainly very tricky. And then, how many permits would a regulator release to achieve optimum in the regulated economy? So this is super straightforward. You just got to find the right box on the board, basically the right answer. Is it going to be Q permits, E permits, A permits, or A over phi Q permits? Remember, these are the social planners that have answered. Right. This is what the social planner chooses to emit, so then you can release that number of permits. Yeah, so that's like super straightforward. And what will the permit price be?
Shouldn't it be W2?
W.
Yeah, V2.
W2. Yep. Because, I mean, you can do the math, but basically, the way that the functions are set up, if you've got an internal solution, your marginal abatement costs are always going to be W2, because you've got this linear abatement function. So you're either going to be at a corner, or you're going to have marginal abatement costs of W2. So actually, I didn't really think about this when I was doing the question, but I should have put in, like, assume an internal solution or something, because you could also be at a corner where you'll never be at a corner with zero abatement. No, sorry, you'll never be at a corner with zero emissions, because you can approach that corner as parameters approach infinity, right? It's because of the shape of the damage function here, which is like this. Marginal damages approach zero as emissions approach zero, so you're never going to quite get to zero emissions. But marginal damages hit, if this is profit maximizing quantity and this is consequent emissions given that quantity in laissez-faire, and if the marginal cost of abatement is up here, W2, then you're not going to do any abatement. Okay. So there is a possibility here of a corner solution with no abatement. So I really should have had that in the question, either to investigate, to account for, think about the corner solution as well, which would make the question even harder, or just say, assume an internal solution. Okay. So if you've got an internal solution, the marginal, it's always going to be W2. Okay. So, quite tricky. Maybe too tricky. Let's take a break and then look at part 2, which is much more straightforward if you've got that far. So how long a break should we take? 10 minutes? Yeah, okay. So see you back here about 1:30 then. What was really going on in that first part? I mean, it's tricky to capture because you've got 2 dimensions with abatement and quantity. So you can't really capture it properly in a simple picture without doing more work. But very broadly, this isn't exactly right, but you've got the damages doing this. So this is like sort of cost benefit somehow. And then you've got these fixed costs, haven't you, for abatement and for production. But it's actually more complicated than this because you've got the 2 dimensions here. You've got quantity, you can adjust quantity and you can abate. So it's more complicated than this. But in part 2, it's different because then in part 2, what have we got? Now we've still got the linear costs, but now we've got linear damages as well. So what's going to happen?
No internal solution.
You're definitely going to get a corner solution, aren't you? So the question is, do they all abate or do none of them abate? Okay. And of course it's really helpful if you can just see that. But otherwise it will fall out of the math. But if you can see it, then it's going to be a lot easier to do the math.
Could you already see, because what is it, beta?
Yeah.
Because it's bigger than W2, that it's probably all abatements or
Yeah.
something?
You could see that, absolutely. You could see that straight away, just by looking at this, and if you've got it clear in your head what's going on. Because this is basically, this is the marginal damages. Theta is like the marginal damages for emissions. W2 is the marginal cost of abatement, which is like negative emissions. So marginal damages are bigger than marginal cost, always, because there's these linear functions. So you could just write down the answer here. Now I've got that in my head, I can't even... Yeah. I have to look at the crib sheet. Yeah, so what's a bit unclear is, part 1, what proportion of power stations fit scrubbers now? Oh, it should say in laissez-faire, in what, under what circumstances here? What I'm thinking here is, or what do you think I'm thinking? Yeah, in first best or in the social plan. Because otherwise it's kind of trivial in laissez-faire. Well, it's still 0. So yeah, it's social plan. So what does the social planner's problem look like? It's this, isn't it? But like that. And then if we take the first order conditions in Q, we get P0 minus Q minus W1 minus theta times phi equals 0. And if we take the first order condition A, we get minus W2 minus minus theta equals 0. So we get W2 equals theta. So we can just look at this and say, look, this is saying that for an internal, because the first order conditions apply in an internal solution, right? So this says for an internal solution you have to have W2 equals theta. Which by extension says if and these are just parameters, so if W2 isn't equal to theta, you're not going to have an internal solution. And we've already been told that theta is greater than W2. So you could sort of do this math and then say, oh, there's not an internal solution here. And then you need to just think, okay, which corner is it going to be? And like Friedrich was reasoning, you've got to realize, okay, it's going to be, which one was it? The clean corner. But of course, it's so much easier if you've already looked at this and realized that it's a corner solution and a clean corner. Otherwise, you could sort of do this math and then you'd like get this and it's like, what is it? I don't get it, you know. Do you see what I mean? This could be, if you haven't got that thought somewhere close to the surface and you get this answer, it's like, what? Okay. So this part is really, it's super straightforward if you've got your head around it. Because that's it, right? They all do. Part 2, so what would optimal regulation be? Could you have tradable permits, Pigovian tax, or command and control like a technology standard? Which is best? Give me some thoughts.
We said that technological standards when we were discussing before. That would be the cheapest way, since we want everyone to have this covered.
Right. So could you have a tax? Right.
Like a really high tax.
Well, you just need to set it at theta.
Yeah.
The Pigovian tax would be at theta, wouldn't it? Because that's what marginal damages are. And then no one would admit anything. And you could even have tradable permits. It wouldn't really make much sense. How many permits would you release if you were having tradable permits? Yeah. So it wouldn't really make a lot of sense to call it a tradable permit system. But kind of in theory you could have any of the three. But I totally agree with Ian on the three of which of you was it working together. Doesn't matter. That why not just ban, you know, why not just have the technology standard? And of course, there is actually an argument, which is that maybe you think they're all the same, but they're not. Maybe it's actually 3 that is true, not 2. So So if 3 is true, and you actually don't know the costs of the different plants, but you do know the damage function, what should you do then? So you know this, but you don't know the details about the different plants, their W2s, if you like. Go on, Hannah.
You said it's tax equal to theta.
Johanna?
Yeah.
Yeah. And this is linked to that. You remember the graphs and stuff I showed you before with like which is best, tradable permits or tax when there's uncertainty? You can link this to that. That here we know the damage function, but we don't know the cost function. For the firms, and the damage function is completely flat. So, therefore, we don't want to regulate quantity because we don't know the first best quantity. But we do know the first best marginal cost. It's always going to be theta. So therefore, a tax is preferable to permits. We wouldn't know how many permits to release in this case. Yeah. Hello?
Hmm?
Yeah. Okay. Yeah, so in a way, my feeling with this question is, it's kind of fine, but it's kind of tricky because you haven't had enough other questions like this to practice on. That's my concern. I don't think it's that hard really, but it's different enough than the ones you've had to practice on that it makes it tricky. I'll have to think about that over as I'm putting the exam together, how to deal with that. If I can get out another question or two, or what, we'll see. But what I said at the start still holds, that this is like at the outer edge of trickiness, for sure. Okay. Shall we, or any questions on this one? Should we go on to the next one? Or comments, whatever. Should we go on to the next one? Yeah. So I'm going to